So EUMETSAT is the European Organization for the Exploitation of European Satellites. We are an intergovernmental organization and we currently have 30 member states. Our task is to serve our member states with satellite data for the purpose of, first of all, weather forecasting, but also for climate monitoring and other environmental monitoring. This starts from developments of satellite instruments. It goes via launching satellites, operating the satellites when they are in space, distributing the data in near real time, archiving the data, develop and deliver satellite-based products, and also distributing them. And it also includes user support services of various kinds. And one of the examples is are the short courses. We are also part of the European Commission's Copernicus Earth observation projects, and we also operate Copernicus satellites. These are the satellites that are currently in orbit and that are operated by EUMETSAT. So we have geostationary satellites, the METEOSAT satellite series. We have the METEOSAT Prime and backup satellites, and we have one satellite over the Indian Ocean. And in the not too far future, we will launch the METEOSAT, the third generation of the METEOSAT satellites. Launch is planned in 2022. In the low Earth orbit or polar orbiting satellites, we have 3 METOP satellites currently in orbit, METOP A, B, and C. We operate Sentinel-3, A, and B, and we operate Jason-2 and 3, and soon we will have Sentinel-6, which is of the same category of satellites that will be launched on November 10th this year, so very soon. This is just to give you a little bit of an overview. I guess I know. So the program for today is we are now in the welcome and introduction session. And after my talk, I will hand over to my colleague at Deutsche Wetterdienst and team leading the radiation team of the climate monitoring satellite application facility. After that, we will have an introduction on how to work with CMSAF data by Steffen Kote. And after Steffen's introduction, you will have a couple of hours from 1 to 3 UTC to play with the data a bit and to apply what Steffen has shown to you. During all of that time, you can always ask questions on Slido, and we will do our best to answer them. And after the hands-on session, we will meet back here in this room, if you wish, at 3 o'clock UTC to go back to your questions and answers, and also to discuss what you have done in the hands-on phase, how the hands-on phase works, and what possibilities you have sharing your results will be explained later on by Steffen. For more information on how to play with the data and some background information, you have the Moodle page here. Rosa, maybe you can once more paste the link into the chat so that everybody can access it. But for now, let's focus on the presentations. So what does a satellite actually measure? What a satellite actually measures is either reflected radiation from the Earth or radiation that is emitted by the Earth's surface. Because we know, at least largely, how this radiation interacts with the constituents of the atmosphere and with the conditions at the surface of the Earth, we can retrieve information about several variables and also climate-related geophysical variables of the Earth, of which one of them is, of course, solar radiation. The retrieval of geophysical variables is developed, or different retrievals of geophysical variables are developed by EUMETSAT itself, but also in close cooperation with experts we have in our member states. And to use this expertise as much as we can, there were the satellite application facility networks set up a couple of decades ago, actually already. So the satellite applications facilities, or SAFs, are dedicated centers of excellence for processing satellite data. So they do research on certain, in their area of expertise, develop the retrievals and deliver the data to you. We have 8 different SAFs. We have a SAF for numerical weather prediction, for ocean and sea ice, for nowcasting, for land surface applications, for atmospheric composition, for radio occultation monitoring, for climate monitoring, and for hydrology. And each SAF is a consortium of entities of EUMETSAT member states. These are mostly the Met services, but also other research institutions and universities. And today, you will learn a little bit about the CM SAF, and you will hopefully learn much more about their solar radiation data. So the SAF on climate monitoring is composed of the consortium that is laid out here. I won't read out all of this. You can read it yourself, and you're also welcome to go to the CMSAF webpage where you find details on this. So climate monitoring, why do we even monitor the climate? Well, because climate is an issue these days and it's becoming increasingly critical. So there is clearly a need to observe what is going on as regards to the Earth climate, in order to be able to understand the processes, because only if we understand the processes we can model and we can predict the future, and we can decide on mitigation and adaptation measures. So nowadays climate data records, also provided from the CMSAF, are used to validate and to improve climate models. But they're also used to analyze trends and variabilities in the Earth system and in the Earth and in the climate of the Earth. The CMSAF is retrieving basically geophysical variables on the energy and water cycle of the Earth. So on the right-hand side, there is a outline of the entire thing here shows you the variables that are included, or whether the CMSAF is mainly dealing with the energy and water cycle. And today we're gonna focus primarily on the solar radiation components of that system. And for that, I would like to welcome the experts on the climate data record of solar radiation, which is Jörg Trentmann, Uwe Pfeifroth, and Steffen Kote. All of them work at DWD in the CMSAF team. My name is Christine, I already mentioned that, and I do my best to moderate this session today. But before we get started with the details and into the science of that all, we would like to know a little bit about you. And for this, we would at this stage like to ask you to go to Slido, where you will find a poll. Rosa will open that poll now, and where you will have time to answer this question, so that we know a little bit more on where you're coming from, what your experiences are as regards the data we're going to talk about now. And I will now stop share my screen and hand over to Rosa. don't be shy and answer your, just enter your answers. It's anonymous. I see that most of you, or some of you, have already worked with NetCDF data, which is nice. Well, and many of you have already worked with CMSAF data. Okay, but most of you have not worked with SARAH data yet, so it's great to have you here. I see. Yeah. Most of you have not worked with CMSAF data. Sorry, I confused that. Okay, it looks like the majority is living on the EUMETSAT disk. And Jörg, this is then for you maybe to take up to explain also to some people what we mean when we talk about the EUMETSAT disk. Okay, maybe at this stage, Jörg, you would like to take over?
Yes, I can do so. So welcome everybody. This is Jörg Trentman from the CMSAF, and yeah, thank you for coming around and joining our short course here. So it's interesting to see, or it's yeah, very nice to see so many different people from different locations joining this course. And I will try to, in the next like 25 minutes, introduce to you the climate data record we are generating for surface solar radiation. And I will also, of course, let you know what actually is the EUMETSAT disk. So I see that well, at least 44% might not be so sure whether they live on the EUMETSAT disk or not. So I will maybe start sharing my screen now. So this should do it. Maybe Christine, can you briefly comment whether you see my screen?
I see your screen, yes.
Okay. So this is about the climate data record of sunshine, and we named it SARAH. So this is just a brief sketch on to introduce SARAH and also Clara, another climate data record of surface radiation that we are generating in the CMSAF. So SARAH was actually born on January 83, so she's 37 years old now. She's multinational. She has a very sunny attitude and actually counts every sunny hour. So she's enjoying being in the sun. Clara, she is actually 1 year older, and she's a truly global citizen. So this is a global data record. She has her feet on the ground. So this also includes some ground information, this data record, which is a surface albedo. She is also sunny-minded, so the data record also includes solar radiation, but also cloud information. So Clara is also enjoying the nice shapes of the cloud. But today, of course, we would like to focus on the SARAH data record that does include mainly or only surface solar radiation data. But the first thing I would like to mention is what is the climate data record and how can we derive such a climate data record from satellite? So, of course, we need a climate data retrieval system. So to start with, we have big data. And the big data is raw satellite data from 30 years or more. So very often, of course, we use EUMETSAT satellites, the EUMETSAT satellites. So this data is, as I said, raw data, and it also can be very messy, because in particular in the early years of the satellite data in the 80s, this data wasn't meant to be used for climate data records, but it was more information to look at for the weather forecast. Still, it is available and it is used to generate climate data records nowadays. However, of course, you need some smart people, some algorithms, and a lot of computing power, namely CPUs, but also hard disk, to get from this messy data record to a ready-to-use data record that then includes a geophysical parameter. So this, of course, it's also a big data again. So it's a big data record, but it is cleaned up. All this messy data from the satellite has kind of turned into a geophysical data record, geophysical parameters. This, of course, can include like cloud information, water vapor. In our case, we are focusing on the surface solar radiation. So what is surface solar radiation or surface irradiance? It's essentially the solar radiation that reaches the Earth's surface, and it is determined by those factors shown here. So the main determinant is the astronomy, of course. So obviously during nighttime, the solar radiation is zero, and then of course it increases as the sun rises during the day. The second most important parameter determining the surface irradiance is the cloud coverage. So we all know if it's a cloudy day, it's not as bright as on a sunny day. The other parameters are the water vapor, the total water vapor, the surface albedo, and also the aerosol content and the properties of the aerosol in the atmosphere. But I would think that those three are maybe second-order effects. So the good thing is that we know astronomy very well. So as long as we know where we are and which date and which time it is, we know more or less the solar zenith angle and can estimate quite well how much solar radiation would reach the surface if there would be no cloud. Luckily, the cloud coverage, we can pretty well also estimate from satellite measurements. In particular, since we are only interested in the cloud coverage during daytime, which is a little bit easier than cloud coverage during nighttime. And the other properties, there are other sources like reanalysis data or climatologies where we can get this information from. So from the satellite, what we need is the cloud coverage. So this is already the argumentation why we can accurately derive the surface solar radiation from satellites, because we can detect clouds during daytime, and the clear sky solar radiative transfer is pretty well understood, and we can have a good simulation on that. So to the right side, you see the visible satellite image. So this is what the visible channel of the EUMETSAT satellite sees. You can see Africa here in the center, Europe, and some slices of South America here as well. And by eye, you can truly detect the surface, Africa, and the clouds. So they are obviously can be distinguished in the satellite image. So the algorithm that we now use is to separate the signal that we see in the satellite from the surface and from the clouds, because the latter we need to estimate the solar radiation. And to separate the clouds from the surface, we use an algorithm which we call the heliostat algorithm, and that first determines the part of the signal in the satellite that comes from the surface. And to estimate that, we calculate the minimum reflectivity for a certain month. In this case, on the left-hand side, again, it's the observations from the satellite on September 2008, 2nd September. And on the right-hand side, we see the minimum reflectivity for all September days. And the assumption here is that during September, there was very likely a clear day. So what we now see on the right-hand side is basically the clear sky reflectivity. And this is without any clouds. So that's, this is like the background that the satellite would see if there would be no clouds. So now we take the difference of the actual observations, which is in this formula here, R, and we subtract the surface reflectivity, the surface reference, and then we get the so-called cloud index. And also we normalize it here again, but that's not so relevant at this stage here. So what we now get is the cloud index, seen here on the right-hand side, that only contains the cloud information. So of course you can still kind of see where Africa, for example, is, but that is because, of course, also the clouds form at certain regions, and obviously the desert in Northern Africa, there are very few clouds, so you can kind of guess where Africa still is. But still, the satellite signal is basically the clouds here, and this is what we need. So you can also distinguish between bright and not so bright clouds, and the bright clouds, they are so bright because they reflect the solar radiation back into space. And every solar radiation that's reflected by clouds cannot reach the surface anymore. So that is kind of reduced from the parameter we are looking for, which is the surface irradiance. So with this cloud index, we can estimate the surface irradiance by from allowing the clear sky radiation. So N in this formula is the cloud index, and the inverse, so 1 minus, is basically the reduction of solar radiation by clouds. So if that would be 0, the surface radiation, which is G all in this case, or for all sky, would be like a clear sky solar radiation. But then we have the reduction of the clear sky radiation by clouds, and that is measured by the cloud index. And the clear sky solar radiation we can calculate, as mentioned before, with the clear sky radiative transfer model, assuming that we have good information on the auxiliary parameters, water vapor, albedo, aerosol, and possibly also other components of the atmosphere. So this estimation we need to do for every single satellite image we have for the last 37 years to get this climate data record. And you can imagine that not all the original satellite images are as nice as the ones I showed here. Some are pretty messy, so we need to do some corrections or constantly how to clean up the original data. Then we do also have a method to calculate the daily and monthly images. Yes.
Can you hear me? Your sound, your sound, at least on my side, is not very well. Maybe you would like to repeat your last few sentences.
Okay, so we have a cloud index. So cloud index is just the impact of, it's basically the cloud brightness. So the brighter the cloud is, the larger the index. So the brighter the cloud, the more radiation is reflected back into space. And the less radiation reaches the Earth's surface. So to estimate the radiation at the Earth's surface, which is G all in this formula, it would be the clear sky radiation, which is without any clouds, and then 1 minus the cloud index. So it's a normalized index. So it goes from 0 to 1, basically. So this is a way to estimate the all sky solar radiation. Christina?
So the basic idea is to separate cloud, the information that comes from the clouds, from the rest of the information.
Exactly. The visible satellite image has both information from the surface and from the clouds. And what we need to estimate the surface radiation is only the cloud information, of course. So we need to somehow remove the kind of the signal from the surface from our satellite image. So that is the key, the main strategy behind this method. And this method then we have to apply for every satellite image over the last 35 or 37 years. We have to develop a good method to estimate daily and also monthly means, provide this data on a proper spatial grid, and then that results in the data record that is called SARAH. So the SARAH data record contains a handful of variables, the global radiation or the surface irradiance, and we have certain abbreviations for those as well, SIS in this case. We are also kind of counting every hour or every time slot that is sunny, and that then gives us the sunshine duration, so the hours of a day that are sunny being defined as a radiation more than 120 watts per square meter. We are also providing direct surface irradiance data, the data on the horizontal surface, which is SID, and the DNI is a direct normalized irradiance, which is the radiation that goes directly from the sun to the surface. I think these are the four main parameters that are used most commonly from the SARAH data record. We're also providing this spectrally resolved irradiance and the cloud albedo that is used to generate the other main surface radiation parameters. The spatial resolution of the data record is 0.05 by 0.05 degree, which is about the original satellite resolution. However, we do regrid the data to a more user-friendly regular Lonlat grid.
Jörg?
Yes?
Sorry to interrupt again. Just to remind you that you also wanted to explain what the EUMETSAT disk is, and I was wondering if this would now be a good spot as we could see it on this slide.
Exactly, that would be in the coverage. We have the spatial coverage is the EUMETSAT disk, and that's actually what you can see here. It's basically a circle with a center at 0 degree at the equator. So probably is the equator probably here. So this spot, that's at where satellite sits at about 36,000 kilometers, and it views this the circle of the Earth basically. So the radius of the circle is about 65 degrees. So this is what we consider the so-called EUMETSAT disk, for those of you who have not been aware of what the disk is. The temporal coverage of this climate data record is from 1983 to 2017. So this is a data record that has, as I said, a beginning, 1983, but also an end. So we did our best to have a very stable, consistent data record. And we used very homogeneous input data from the satellite. So that's why we stopped it at some point. However, for some applications, it would be nice, it is actually required to have an extension in time of this data. So for this, I would like to introduce an interim climate data record, and that's what this sketch is about. So on top, we have the satellite measured signal, in our case, just a visible channel from the satellite. And to generate the climate data record, we use some kind of homogenization, a well-defined data record, and we have the climate data record, which has in the beginning and the end. In parallel to this climate data record, we now also have an interim climate data record that uses the same algorithm as we use for the climate data record, for the CDR, to retrieve the surface irradiance and sunshine duration in this case. However, of course, we cannot apply all the homogenization steps we use for the CDR. However, obviously, the latest satellites from EUMETSAT are much better quality and are much more stable than the historic ones. So those two data records, the interim climate data record and the climate data record together, they can be used to monitor the climate and to say, for example, the last month, September 2020, was more sunny than the average, or less sunny, or about the same, or something like that. So these two data records can be combined. So the SARAH ICDR we are providing has a very comparable resolution and coverage as the climate data record. However, we focus on the four main surface radiation parameters: the global radiation, the sunshine duration, and the direct irradiance. It is available, as I said, with a very high timeliness, starting on 2018, 1st of January, and it should now be available from the day before yesterday, so probably the 26th of October, maybe 25th. So it actually can be used for operational climate monitoring. So that's the introduction into the data, but what can you do with this data? So there are already many applications, and I should probably also mention that that these data are freely available without any restrictions. So you can go to the website, order the data, download the data, and do whatever you want with it. So there are many applications already. Some include climate analysis, climate monitoring, model evaluation, be it a climate model or weather model. It is used a lot for solar energy assessments, also in the field of agrometeorology, agriculture. It is already in use, and there are many other fields as well. So of course, for us, it would be very interesting to learn what you would like to do with the SARAH data, or how actually SARAH might be able to help you in your work. But surely this is probably too much to discuss here. But maybe you can send us a message, or maybe in the afternoon session when we collect some feedback. We would be very interested to see how this data can help you. The first question you should ask is the SARAH data actually good enough for your application? So this is, of course, always a good idea to ask, can I use the data? Is the data what I'm looking for for my case? So, and to answer this question, of course, one needs to define what is good enough in your case. So what I'm suggesting is to first have a look at the data, and then use available information or make your own assessment to conclude whether the data is suitable for you. So, and this is what I'll be showing in the next slides. So this is a first look at the data. And since I'm living in Germany, this is just a figure of the climatology of the surface irradiance for Germany. And I see that in the northern part of Germany, there's less radiation in the southern part of Germany, which is as I'm aware, so that's how it should be. Also, I can spot some areas with mountains, like the Black Forest and the Rhine Valley, which experience more solar radiation than with the Black Forest. So this looks very reasonable to me for Germany. The next thing I would do is to look at the time series, and this is a place where I also live. This is in Offenbach. This is just the time series of sunshine duration over the last 35 years, and it also looks reasonable. This is a climatology. Obviously, in summer there's more sunshine duration, longer sunshine hours than in winter time. There's also some variability from year to year. This is the annual means. So for the 35 years, and here the year 2003 sticks out with a very high solar radiation. Also, that I can still remember that was a year that was very warm, very bright. So that also looks very realistic. So just by looking at the data, I would conclude the data, in fact, does look very realistic and potentially can be used. My next suggestion would be to have a look at the documentation that we are providing. So the CMSAF provides a lot of documentation on the algorithm, on how we generate the data, where it can be found, but also on how it compares to other data records, in particular with reference data. So for the SARAH data sets, we use the so-called BSRN network, baseline surface radiation network, which is a global network providing high quality data of the surface solar and long wave radiation. So we use the SARAH data record and this reference data and do a lot of comparisons. So this is just an example of just a correlation between the surface data on the x-axis and the SARAH data on the y-axis, and yeah, the correlation is very high. This is a time series of the bias, so it is also very stable. So we do not want to see a change in the bias over time, because that would then indicate some instability. We do provide this information also for all the stations that we gather the data for. I think in this case it was 15. This is a mean absolute bias, and yeah, you can see that the data quality is different for different stations, or can be different. So the station has a slightly higher mean absolute deviation than there may be others. So, but in general, our conclusion here is that the data is actually accurate and has a high stability at those 15 stations that we have access to. So the third step to answer this question, is the data good enough, could be to check out the review, check out the literature that's available in the peer-reviewed literature. So there are already many articles referring to SARA data records, and many, of course, also deal with the validation. We have the reference list of all papers put on the short course page. So these are just 3 examples. One is from Norway. So they also validated the SARA data with some ground observations from Norway. I found a good correlation. This is from an article using data from Poland, and an article that uses daily data from different European countries to get to this result. So overall, the conclusion of these studies is that the SARA data is of high quality and suitable for many applications. But of course, the best thing to do is to assess the data by yourself if you have the chance to do so. So you can compare, you should compare maybe the SARA data with your own reference data. But that, of course, requires that you do have high quality surface reference measurements, so that you should use. It is also important to recognize, to remember that the SARA data always is representative for a certain area. So it's not really a point measurement as the surface measurement, but it's representing an area of about 5 by 5 kilometers or 25 square kilometers. So if this reference data is very local, then you can expect some differences. Also, you want to make sure that the units of the data match. So the SARA data is provided as averages, daily or monthly averages, average fluxes. So the average also do include the nighttime values. So it's day and night. Of course, for the sunshine duration, we're providing the daily and monthly sums. Sometimes the surface observations are given in also in sums, in daily sums of surface radiation. So these can be intertransferred. The month daily means and daily sums, there's just a factor. But of course, you need to be sure that you have the same units. And also, just make sure that you are open for surprises in the reference data. That's what we are finding, that sometimes when we compare the data, the satellite data to reference data, that we find some weird things, and that are not due to the satellite data, but sometimes also the reference data, which we thought would be perfect, might not be perfect in the end. So of course, here we are very much interested in what your conclusion will be if you have your own reference data to compare the SARA data with. So then hopefully you conclude that the data is suitable for your application. So now I will give a couple of slides on what other people did with the SARA data record on climate analysis, solar energy assessments, quality control of surface measurements, climate monitoring, and other things. And you can find more applications also on our web page. These are applications that have also, they do have some web interface, and these are linked to our web page. And if you have applications that you want to share with us and that we might be able to link to, just let us know. So this is a climate analysis and a trend analysis that we did using the SARA data record. On the left-hand side, you see the so-called sunny days. So he basically counted the days for a certain location. In this case, this is Frankfurt, the center of Germany. How often a certain day of a year was what we considered sunny. We had a definition of when is a day sunny. But here it turned out that the day of the year with the most likelihood of being sunny is 17th of August. So mid of August, if you want to visit Frankfurt and you like the sun, come to us in the mid of the summer, basically. And we do provide these and other curves also on our webpage for a number of cities worldwide. On the right-hand side, this is a study from a colleague of mine, Uwe Pfeifroth. he compared the trends of the SARAH data record with those from surface stations, and this is the main figure of this publication, where you see that in general we have an increase in surface irradiance, which is a global brightening that is well known in the literature from the SARAH data and also from the station data. And on average, there's a good correspondence between the station data and the surface data. We do have some larger deviations maybe here in the Mediterranean area, where the surface data suggests an even stronger brightening than the satellite data. In particular, during summer, we see this effect. But still, we think that SARAH data can actually be used to at least estimate the trends and changes in surface irradiance. I mentioned that SARAH is used a lot in solar energy modeling. So here are just 3 examples. So the PVGIS from the JRC in ISPA is a very prominent example, where you can get information on the potential for building a PV plant, like on your rooftop or just somewhere else. You can click on a map and estimate how long it would take to get your finance back from the assuming a certain price for your PV installation and the power you get and so on. So this is a very well-known source of information in the solar energy field. The same is true for the Renewable Linear web page that also provides information from the SARAH data record, and also provides the possibility to download longer time series. On the right-hand side here is a sketch from figures from a publication from a colleague of ours, and she looked at the possibility to complement solar radiation and wind energy in Germany. And it turns out that on average, at least, the combination of solar, which is shown here in red, so the annual cycle, and wind energy is more or less constant throughout the year, on average at least. So the both forms of renewable energy at least have the potential to provide a rather constant electricity flux in Germany. The next application I would like to introduce is the quality control of surface measurements. So this is from Ruben Uraka. He set up a web page and developed a method to use satellite data, in this case SARAH and not SARAH data record, together with reanalysis data to detect problems in surface measurements, like, for example, soiling, when there's just dust on the instrument that measures the surface solar radiation. And this is, for example, yeah?
So this means that the confidence in the SARAH climate data record is actually that high that you use it to compare ground station measurements against, so that you use the SARAH as a reference?
Yes, in fact. So it's turning the clock around, basically. Of course, you want to validate your satellite data in the first place, but yeah, as you say, the confidence is pretty high. As many others have a high confidence, and so do I, in the SARAH data record. Still, of course, it's even more reliable if you use multiple data records. In this case, the SARAH together with the CLARA and some reanalysis data record. So if all 3, for example, in this case here shown in this orange part, this is a time period where the deviation between the surface data and those 3 reference data increase over time, and all of a sudden then decrease again, it is unlikely that the 3 independent data records have a problem here, but it's more likely that it's the surface data. And in this case, it was concluded that actually it was soiling, and at the end of this period here, there was some rain, 3.6 millimeters, that again cleaned the instrument. So that is one application that actually can be used now by everybody. So they have this web page here, the BQC method, where you can upload your data and check it against those 3 good data records to see whether there are any inconsistencies in the data. And then, of course, climate monitoring, which is what the CM stands for in the CM SAF. So for climate monitoring, So this is an example from last year. Last year was actually a record year in sunshine duration in Europe. This is the anomaly of the sunshine duration hours in 2019 compared to the reference, and almost throughout Europe, maybe except of Scandinavia, it was a positive anomaly, and it had never been so sunny than 2019 in Europe, at least for the satellite data record starting in the 80s. There is a regular monitoring from the WMO Regional Climate Center. So this is an example for the last month, September 2020. So again, there was a positive anomaly, so more solar radiation, longer sunshine duration than average in Central Europe and also in the eastern parts of Europe. And we did an estimation for 2020 so far, so till the end of September. And it's essentially the same figure than the September figure, with a positive anomaly, much more solar radiation, much longer sunshine duration, I should say, in the central and in the eastern part, also in Scandinavia this year, than on average. Only the Iberian Peninsula is like in the average figures of sunshine duration. So we also look at Germany in this case. So in Germany, we are on number 3 currently for the sunniest years. So, and these figures here on the right-hand side, they're actually being prepared with the CMSAF R Toolbox, and Steffen will later also introduce a little bit on this feature. So that was basically the end of this part, and now I would like to have some final words, basically. So some suggestions from my side. So if you want to get started with the SARAH data record, I suggest to minimize the size of your order or the data download. The full data record is pretty big. So you want to specify a certain region that you are mainly interested in. Maybe you want to start also with monthly averages, just to get an overview, and not with the instantaneous 30-minute data, which is a lot of data. So this all can be done while ordering the data, so you don't have to download the whole thing. Of course, it's always advisable to read the documentation and the references, in particular if you want to do some real applications. Of course, yeah, just look at the climatology. Yeah, you should be able to do this without digging too much into the documentation. But of course, as there is documentation and also a lot of references, make sure to have a look. As I mentioned, you have to make sure to use the proper unit, the unit that you need for your application. SARAH data is in average fluxes. And I suggest to use the CMSAF Toolbox. In particular, if you are not familiar with the netcdf files, of course, you can also use any other tool you are familiar with and you prefer, if you're familiar with netcdf files. So that's, of course, fine. Also some words of caution and some known limitations. So we already know that the SARAH data tends to overestimate surface radiation and sunshine duration in West Africa. And we are working on this issue, but if you want to dig deeper into that region, make sure to be aware of this issue. The trends and the changes that in the surface irradiance and sunshine duration are mainly dominated by changes in the cloudiness. So we do not have aerosol changes implemented in the satellite retrieval. That is also one issue you might want to keep in mind, that it's mainly the clouds that drive the variability and the change in the SARAH data. Then also we discovered that the SARAH data record, the SARAH 2, underestimates the surface radiation over snow-covered surfaces. And I will come back to this feature in a second, because that will be improved in the next version. So the CDRs, the climate data records by the CMSAF, they are also regularly updated, and kind of a new version is put out. And for SARAH, there'll be a new version probably by the end of next year. So in 1 year from now, there'll be a new data record covering again the full time period 83 to 2020. This then also includes the new WMO climate reference period. It does also include new spectral parameters, in this case, photosynthetic active radiation and the daylight. And has an improved retrieval and hence also an improved data quality over snow-covered surfaces. And here I want to just show you an example for a parametric day in the current SARAH data. So this is a 10th of March 2010. On the left-hand side, you see a satellite image. And if you're used to satellite data, you can immediately see that on the northern part, it is thick clouds. In the southern parts, they are thin clouds. And in the center, these bright areas here, those are not clouds, but this is snow cover on the surface. So what the current data does, the bright parts here, they are depicted as clouds, and the solar radiation is reduced because currently we cannot easily distinguish between clouds and snow cover on the surface. However, with the new data record, the SARAH 3, at least we try to distinguish between the snow and the clouds. So here in this case, at least we do have an enhanced solar radiation at the surface compared to the SARAH 2 data record. Also the correlation with the surface data, these are shown here as the circles in the spatial plot here. So this is improved. Of course, it can still be further improved, obviously, but at least the performance is better than the current version of the SARAH data record. So this is also one note of caution. If you analyze the data over regions with a lot of snow cover, yeah, be aware that there might be some issues when there's snow cover on the ground in the satellite data record. So this summarizes my presentation. So I hope I could convince you that the SARAH climate data records, which is the CDR and the ICDR, they do provide high quality data of the surface solar radiation and sunshine duration. That also has a high stability for Europe and for Africa. There are numerous examples that document the suitability of the data for a variety of applications, and I invite you to visit the webpage of the applications or to have a look at the list of references. The combined use of the CDR and the ICDR is allowing climate monitoring. We will improve the data record, in particular over the snow-covered surfaces in a year from now. The CMSAF R Toolbox provides an easy start for data exploration. So that would be my suggestion if you want to continue this afternoon. Have a look at the toolbox, order and download some data, and hopefully we can then later on discuss some climatologies of the SARAH data record for your area. So the SARAH data are freely available as all other CMSAF data as well at this webpage. And with this, I thank you for your attention and give back to Christina, I believe.
Yes, thanks very much, Jörg, for this very nice and very interesting talk. There are a few questions on Slido, and Jörg, if that's okay with you, I would suggest to take them now before we go on with the introduction to the toolbox. Is that okay?
Yes, of course.
Okay, Rosa, would you be able to share the questions that are on Slido? Thank you. Okay, so first question is, how about the areas by which that are not covered by the SARAH data record?
Okay, yeah. How about it means how can we get data? I assume that would be the question.
I would assume that this is the question, yes.
So the CMSAF provides, of course, the CLARA data record, as I just mentioned. That is a global data record. So there also are some white spots on the map, but in general, you should be able to, as part of the CLARA data record. The CLARA data record currently ends in 2015, but yeah, within the next days, actually, we will provide the data till the end. Till mid 2019. So that should then, in this context, at least provide daily and monthly surface irradiance data. Unfortunately, we do not have sunshine duration from the CLARA data record.
Okay, but this would also be available via the CMSAF web user interface, right?
Exactly, yes.
Okay.
And maybe we can also share the link directly to the CLARA data record in the Slido later on. in addition, we also do provide data from the so-called EUMETSAT East satellite. That is like the same satellite we use for the SARAH data, but this is shifted further east to the Indian Ocean. That data is also accessible from the CMSAF web user interface. This data starts from 1909 till 2016. So depending on what you're interested in, what time period and which area, maybe this is also a data record you might want to consider.
Okay, thank you. The next question I think is more a comment. I think that the page on photovoltaic geographic information system, PVGIS, is very useful. Yes, I do believe so as well. And I will post the link into the chat, and I think we could also have that in, it is in Slido actually. Our colleague posted it on Slido already. Thanks very much. Next question would be, where does the global brightening come from? Is there less clouds in the skies these days, and why? I guess this is a question that could be answered using the SARAH climate data record, right, Dirk?
Well, yes, the question why is very difficult to answer, of course. But since we are seeing an increasing trend in solar irradiance, which is like a brightening, and since SARAH is mainly determined by the cloud variability, so yes, SARAH indicates that there are less clouds nowadays than 30 years ago. Why that is, that of course is much more difficult to answer. There are indications that maybe and we only looked at Europe in this study, that maybe the circulation patterns in Europe have been changed over the last 30 years towards more weather patterns that tend to have less clouds. And we also, of course, we also calculated already the trends in SARAH and other regions on the world. And I mean, there are regions that have more clouds, or at least where there are some reduced solar irradiance. So it's obvious, not at least based on the SARAH data record, not everywhere getting bright or homogeneously. But my current, I would say, working hypothesis is that the circulation patterns in Europe have changed over the last 30 years towards weather patterns that have less cloudiness than averaged in the previous years. But this is just a speculation, of course, and others, of course, also refer to aerosol changes a lot that introduce, and that, of course, that also have their contributions to the brightening that we are seeing also in the surface data.
Okay, and the next question is it possible to measure evapotranspiration and albedo in sultry, cloudy, and foggy weather conditions? That's something not directly relating to the SARAH data record, but maybe indirectly.
What was the parameters that were asked for surface albedo?
To measure evapotranspiration and albedo.
Evapotranspiration and albedo. Yes, that's not my field of expertise, I should say. But I can say that, for example, for the surface albedo, if you do not see the ground, you cannot measure ground properties. So I know that colleagues also within the CMSAF, we are deriving the surface albedo as part of the CLARA data record, and they only estimate the surface albedo when they have a cloud-free satellite observation. So they average over, I think, 10 days or 5 days to have a good statistics of having at least a cloud-free sample. For the evapotranspiration, I don't know exactly what's driving this parameter. I know that the CMSAF does have evapotranspiration of the ocean as part of the UOPS data record, but this is a microwave satellite data that goes into that. Typically, the microwave data actually can cope with clouds, but I don't have the details here. But for surface albedo, yeah, it's difficult.
Mm-hmm. But that sounds like we may want to think about another short course on evapotranspiration and albedo retrieval. There may be a chance that we have this in the next round of short courses. Okay, the next question, is the SARAH output data available in GIS format, like shapefile data?
No, I mean, currently the only format we are providing is NetCDF. This is accessible from the CMSAF Toolbox, from the CMSAF web page. The CMSAF Toolbox actually is able to convert the data into other formats. Maybe Stefan can later on comment on this, whether it can actually export the data into, I think that GeoTIFF, for example, is one format that, I mean, the CMSAF R Toolbox is capable of working with. I assume it's also capable of exporting the data as a GeoTIFF. I'm not sure about shapefiles, but I'm sure about GeoTIFF. So maybe Stefan can comment on this in the next session. But directly from the CMSAF web user interface, we are providing NetCDF data only.
Thanks. The next question is, what is the role of surface albedo when interfering with surface irradiance, and how do you define albedo values for each point on the disk?
So the surface albedo has two roles in our retrieval system. The first role is on the clear sky reflectivity that I showed, how the surface is subtracted from the clouds to get only the cloud information to estimate the solar radiation. So there's now kind of external data used here. So in this case, we use the surface albedo from the satellite information itself, basically. So we don't have any auxiliary data on the surface albedo. The surface albedo is also required to estimate the clear sky solar radiation. In this case, we use some information that is fixed. Basically, we use so far we used climatology, which is actually a rather coarse resolution. So and there's only one value for the whole year. So currently in SARAH 2, there's no annual cycle of a surface albedo. This will change in SARAH 3. We improved, or we updated our database for the surface albedo, for the clear sky information. However, luckily for most of our parameters for the surface incoming solar radiation, the surface albedo has only moderate influence, in particular over surfaces that are not so bright. Because I mean, if you only look at the direct radiation, it will not even touch the surface albedo, because the definition comes directly from the sun. So it is part of the diffuse component of the global radiation. It is modified by the surface albedo, and that is a small contribution to the surface irradiance. As long as the surface is not too bright.
Okay, thanks very much. There is one more question coming in from the CMSAF R Toolbox. Aerosol analysis could be done and particulate matter could be inferred. Where can I find a particular example?
Can we repeat the beginning of this?
From the CMSAF R Toolbox, aerosol analysis could be done and particulate matter could be inferred. Where can I find a particular example? I guess we need to clarify the difference between the R Toolbox and the data here.
Yes, and did you say aerosol can be inferred?
Aerosol analysis could be done.
Aerosol analysis could be done. I don't know what this question is referring to. The CMSAF is providing also an aerosol data record, and of course that can also be analyzed with the CMSAF R Toolbox. But I don't know exactly what the detail, what this question is about. Maybe we can iterate it on slightly a bit more.
Yes, maybe we could iterate on that via Slido.
Yes,
that would be my suggestion for now. So that we can now, I think we are through with the questions. The rest of the questions have been answered already. And I would like to hand over to Stefan to introduce us to how the CMSAF R Toolbox works.
Okay. Hi, it's me, Steffen. Everything fine with the presentation?
I can see your slides well and I can hear you well, Stefan. Yes, please go ahead.
Okay. The presentation title is From Order to Figure. So what this means? Something happening? Okay. So part of this short course is that you will get the chance to work with our SARAH data on your own. So maybe to produce some figures like these here. And in order to prepare you for this hands-on session, I will now briefly recap the information which are provided on the course page. So we would like to hope that you, in the end of the course, you are able to know, or at least you know the basics on how to work with CMSAF data. So this means you know how to order the data, you know how to prepare the data, analyze, visualize, and I hope I can show you how amazing it is to work with our data. So the first step is to get our data. That's so CMSAF data are completely free of charge, and I hope it's quite intuitively on how to get these data. So you can get the data via our web user interface, and you have to follow a few steps, starting with a registration. After that, you will get an email with your login details, and you can log in to the web user interface. And then you have different ways on how to search the data you're looking for. I will show you my preferred way, which is via the so-called product search form. Here you have the chance to filter our products by different attributes, maybe by product family, product name, or some more. In the end, you will get a list of products showing some more details on the products, like the time step. So are you interested in monthly data, daily data, or even higher temporal resolutions? You can select one. And now there comes one very important step, which is sometimes a little bit difficult to find. This is to select a region, because you know we are dealing with satellite data here, and this can be a huge amount of data. We have now time series from covering time periods over 35 years or more with high spatial resolutions, and you can easily get a huge amount of data. And the easiest way to reduce these amounts of data is to just focus on your region of interest and to order only data for your region of interest. After you've chosen a region, you can also specify the time range, and after that you click Add to Order Card, and you will see before you place an order, you will see an estimated amount of the data, but don't be afraid, that's the amount of data without cutting the region. So in the end, if you use this select region option, you will get a much lower amount of data. So now you hit the place an order button, and you will immediately get a confirmation email. And depending on the amount of data you ordered, shortly after that, you will get an email with a download link. Then you can download the data, and you will get the data in form of a tar file. So here, sometimes the difficulties start. So a tar file is a kind of container which includes, in this case, netcdf data, and netcdf for each time step, one netcdf file. So there can be thousands of files included in one tar file. And to make it easier to work with the data now, the CMSAF provides the CMSAF R Toolbox. So this is an R-based tool, but don't be afraid, you don't need any R or scripting experiences. It's everything with clicking, and I hope it's mainly intuitively and easy to use. So the R Toolbox is divided into three main steps. So there's the prepare, analyze, and visualize step. With the prepare step, you are preparing the tar file, which you just downloaded from your order link. So this means in detail, you're extracting the tar file, you're merging all the netcdf files into one file, and optionally, you can choose the time, region, and variable. And the next step, in the Analyze panel, you get an interface to more than 60 operators to analyze and manipulate CMSAF netcdf data, and also other netcdf data. And you can, this is mainly the heart of the toolbox. Here you do all the work. And after that, of course, you want to visualize your results. And for this, the toolbox offers lots of options to adapt the figures to your needs in the end and to make some really nice figures. If you had a look at our course page, you already know how to install the toolbox, and I will not going into detail on how to install the toolbox. If you install the toolbox, you can start it by maybe by using the RStudio and just type CMSAF /run_toolbox and two brackets. That's it. And then have fun. So right after my talk, you are able to start with a hands-on session, and I will briefly prepare you for this. So in this hands-on session, you will get the chance to explore our SARAH data. You can use the CMSAF R Toolbox, or of course, you can also use any other tool you like and which is able to handle netcdf data. You can work in your own pace. So this means it's fine if you're able to create a figure of SARAH data in the end. It's also good, a little more advanced, if you create an anomaly for a country or a city, for example, that might be possible mini projects for this short hands-on session. And to prepare you for this, I will now show you a live demo for this small example on how to create a figure of SARAH data. And after that, we prepared a tutorial video which shows you in detail how to create an anomaly for your country or for some country and a city. And I think it should be quite easy to follow this video. Okay, now comes the difficult part, the live demo. You can see the RStudio, and I will start my toolbox with the run toolbox command. Okay, now you can see the toolbox. First step, like I just explained, is prepare your data. So you downloaded your tar file, now you want to prepare these data to make a nice looking to create a netcdf file which can be handled by the toolbox. So I'm using a Mac, so don't be confused about the save button here. It's a Mac and Linux specific thing. So in Windows, it looks much better. So Now you'll see the included time range, which is included in the tar file. So here are 17 years of data included. You click on untar and these files, and now all netcdf, single netcdf files, which are included in the tar file, will be extracted. Here you can see the region which is included in the data. You can restrict the region if you want to. In this case of sunshine duration, which is here, there's only the sunshine duration variable, but we also have CMSAF data which include more than one variable, which you can choose here. And now you can just create output file. This will take a little bit depending on the amount of data. And in the end, now you have one single netcdf file, including all the data of the tar file. And this is ready now to be analyzed in the analyze step. You will find this file in your defined output folder. You can have a look and edit your output folder directory here. So, and the first task which we usually ask participants at our training workshops is to create a climatology of a country of their choice. So climatology means in this case a long-term mean. So this is a temporal operator, and we're looking for the all-time means. That's easy. So just these two options and click on apply operator. Now all time steps which are included in this huge netcdf file will be averaged into this result here you can see now. So this is a mean sunshine duration from 2000 to 2015. And now you can adapt this figure to your needs and play a little bit around with the options here to make a nice looking figure in the end. You have the option to maybe plot a country. You can include own locations maybe. So I think that would be a nice, easy task for this hands-on session, which you can repeat, I think, for some country of your choice. Or if you just want to repeat this live demo, on the course page, you will find a link to the exact data I used here. So you can easily repeat maybe this task or just play around with our data. The other more advanced example, like I told, is shown in the tutorial video. This is which you can find on the course page or on our YouTube channel. And further information are provided on the Moodle page. And we would be very happy if you could fill our Padlet web page after that with your results, and we're very curious what you are creating. So I think by this, Christina, you will.
Yes, thank you very much, Steffen. So are there any urgent questions regarding the CMSAF R Toolbox and how to use it. I cannot see any on the Slido at the moment. So I think you're fine. So you're now invited to work with the toolbox and the data on your own. Stefan has suggested some steps to do with the toolbox. There are also a few more suggestions on the Moodle page in the so-called cheat sheets that you'll find there. And if you have questions in the meantime, we will have a look at Slido all the time. So please feel free also to post your questions during the hands-on sessions. And since we are now a little bit over the time, I would suggest to give you 2 hours, maybe not quite, but maybe let's agree that we meet back here at 15:15 UTC, so 15:15 UTC. I'll be here a bit early as well to go through your question and answers, and hopefully also to see something on the Padlet. So Padlet is really easy. You go to the Padlet link that's also on the Moodle page, and maybe Stefan, you can post the link also into the chat here so that people could just click on it.
Yeah.
And you can very easily, by dragging, dropping, upload the stuff that you have on the Padlet. And this can be anonymous. I'm sure it is. Stefan, it's set to be anonymous, right? The Padlet.
Yeah.
Okay,
yeah.
so don't worry. Others feel also free to comment on others' posts, but please be polite. And yeah, then have fun playing with the data, and also please remember. How do we do the evaluation, Rosa? Is the link on the Moodle page? Please remind me, or will it be on Slido?
No, it's on Slido. The poll is now active, so everybody can already start filling in the poll if they like.
Yeah.
Yes.
So if you wish to evaluate this course, which we would like to strongly encourage you to do so, you can either do it now or you can wait until after the hands-on and wrap-up session. But please give us feedback so that we can improve. And now have fun playing with the data. As I said, we will have a look on Slido, so you can continue asking questions, and we will answer them also in the meantime. Have fun playing, and let's meet back here at 15:15 UTC. Thanks so much, and talk to you hopefully in a couple of hours. Stefan, du bist nicht stumm, nur zur Information. Thanks, Rosa. Jörg or Stefan, do you want to comment on any of the posts on Padlet? I see here a nice sunshine duration map of Namibia. So I assume this is the average sunshine duration for Namibia for the whole time series, I guess. But so we are not that many people. So Rosa, can we allow people to unmute themselves and speak to us? Is that possible?
Yes, now they can unmute themselves.
Okay, so if anybody of you want to comment on what they have posted on the Padlet, you can just unmute yourself and talk to us, explain. That would be nice. Or if you would like to comment on anybody else's post. Or do you have any questions that you would like to have answered in this Q&A wrap-up session? Don't be shy.
Hello.
Hello, can you hear me?
Yes, we can
Yeah.
hear you.
Oh, I'm sorry.
Okay, I'm Diana from Benin.
Hello, Diana.
Okay, I have some issues about about the tool R tool. So I can get that data, but I cannot implement the R tool on my computer. So the picture that I show on the Windows, I display it with GRAD.
Yes, great. So which
Yes.
one did you post?
Sunshine duration over Western Africa.
Ah, yes, I see it. That looks very nice. I mean, there is, if you're using other software and if you're familiar with it, then it's absolutely no problem. It's great to see also plots from other software here, and I really liked your image. Would you maybe be able to add a color bar to it?
Excuse me, I don't understand what you say.
Okay, you've put a very nice picture of the sunshine duration over Western Africa on the Padlet. I was wondering if it would be possible for you to add a color bar to it so that we know the meaning of the colors you used.
Oh, yes, but it will take
It,
time.
yeah, it does not need to be immediately. I was just
Okay,
wondering.
okay.
Yeah. So the Padlet will remain open for you.
Okay, thank you.
But maybe this is Jörg speaking. Can you kind of have an idea whether this is realistic, what you see? Diana?
Hi, hello.
Hi, yeah, I'm still looking at the figure that you posted from the sunshine duration in Western Africa. So I see some spatial structure with more reddish colors in maybe more Central Africa, and then it gets a little bit more greenish further northwest. Is that realistic, or do you think it should be different?
No, I
From
think
your
it's
experience, I assume you know the area.
realistic. I think this is from January, so it's great. It's
From January.
yes,
Okay.
it's quite realistic, I think.
And is green a higher solar radiation, or is pinkish the higher solar radiation?
I think it's the red one.
The red, okay. So there are more clouds in the northwestern region of this figure, at least. Okay. Yeah, thank you. Very nice. And what was the problem with the installing the R package? Can you briefly?
I think it's an internet problem. It takes a long time to download
Okay.
the that I need.
Mhm.
Yes.
Yes, of course. That we cannot solve easily.
No.
Thank you.
Thank you.
Okay. Stefan, this is now maybe a question from me to you. I'm not sure. There was one plot on the surface downwelling shortwave radiation for Slovenia, and there were some discussions on the projection because it looks a bit stretched, as the author says. I'm not sure, is the current version of the toolbox able to do reprojections and to use other projections? Sorry, I didn't double check.
I recommended at least try playing with the longitude and latitude slider, so you can a little bit adjust the stretching, but reprojecting is possible, but you need another reference.
Yeah, I see.
Yeah.
Yeah, but maybe a hint. Then you could. I don't know who posted that, but you could of course download your result .NET-CDF file and ingest this in any GIS system you may have available, and then do any kind of reprojections you'd like to adjust it to your needs.
Hello, it's Ziva here. I posted the image, and yes, I normally use R in general to produce plots, but I just wanted to play around with this toolbox. And I think it's a very nice tool for people who are not really familiar with programming.
Yes, and you know, yeah, good to hear. And you know that you can also use. I mean, if you're an experienced R user, you can also use just the CMSAF R package and ingest the functionalities in your usual R routines.
Yes.
Very nice. There is one example, which I'm not sure what it. Now it says here. Yes, the fractional cloud cover monthly mean we see here for, yeah, a bit more than is this the EUMETSAT disk? I assume it's a little bit more. So it's probably taken from, I don't know which data set that may be. Is that Clara? I don't know who posted that.
Hello.
Hello.
Hello. Yeah, Ryan from BMKG. Yes, I posted that. So I have some issue with the download the data because the internet connections. So I just pick one example
Okay.
data from
Yes.
website, and I just to show up with using ArchMap because you know the some issue with internet connection.
Yes.
I cannot download the R
Yeah, but
toolbox.
that also does not need to be. So if you're familiar with ArcMap and you're able to do all the processing with that, then feel free, go ahead and use it.
Thank you.
Absolutely, absolutely fine, and would love to see more of your results if you continue using the CMSAF data or the CMSAF radiation data.
And the one thing I should to discuss with you, because the ArchMap can convert to save file, so we can produce more outputs and combine with another data. in local data, I mean. Yeah.
Yes, absolutely. I'm just not sure, but you are the expert. I haven't used ArcMap since I don't know how many years. I don't know how it is if you would like to do a time series analysis on the climate data records. Yeah, but if that works, fine. Otherwise, we can of course always recommend to use the toolbox once you were able to download it and then ingest your results into ArcMap or any other system. Yeah,
Thank you. Thank you very
absolutely
much.
fine. Thanks.
Yeah, thanks.
Are there any questions or comments on the data records themselves that you have used? Are there any, I don't know, suspicious features or values that you have explored or anything that you observed you would like to share here? Okay, well then, if there are no further questions from your side, or have I overseen something, then please let me know. Then,
Hello, Christine.
yes.
This is Ahmed from Nigeria.
Hello.
Yeah, just a comment of appreciation. My data is not yet ready because of internet or something, I don't know. So, but hopefully one will be able to upload the project after this presentation, right?
Yes, that would be possible.
Oh, okay. On the Padlet, right?
Yeah, on the Padlet. Just use this link.
Oh, great.
That we had it. It will stay there.
Oh, great. This is a very good
Yeah.
course. Thank you very much.
Welcome. We'd love to see more. All right. So if there are no further comments or questions, then I would like to give the floor for some, I don't know, for some closing remarks or comments you may have to Stefan, Uwe, and Jörg, whoever may start.
I'll say a few words maybe. This is Jörg. So I'm pretty impressed by what happened in only a couple of hours this afternoon on the Padlet side. So it's very nice to see the figures, different regions from Africa, from Europe, even from South America. And yes, as Christina already mentioned, we will keep this Padlet site open also for a longer time. So there will be a link also in the near future from the CMSAF webpage to this Padlet site, so that it will remain open and for indefinite time, basically. So we plan to have this as a central room where everybody can share their results, their maybe even their problems or their successes, of course, with us and with everybody else. So yes, I thank you all, and of course, if you have questions or run into trouble, do not hesitate to send us a message. CMSAF, we do have a contact email. That's probably the most safest contact point for the CMSAF. Just drop them a line, and they will then distribute it. If it's along the SARAH data set, on the solar radiation in general, probably I will get to read it and will reply to it. So of course, feel free to send us your comments, questions, and of course also success stories. So if you use the data for any application, please let us know. We are always very much interested in seeing applications of our data, of course. So again, thank you all for your participation and your time, and I hope to keep in touch in one or the other way. Thank you.
Thanks.